everyone. We are working on our last bit of factoring polynomials here. Just to give you a heads up, this one's probably going to be the longest video of the 4 that I'm making on this review because we are talking about factoring trinomials, and sometimes that can be a little bit time consuming, but not too bad. So let's go with this one. Now, I just want you to know that when I do this one, I'm going to show you something in just a little bit that I've talked about in class, and it's how we look for those numbers that would help us factor this. So there's 2 ways to do this. One I call the diamond model, and the other one we're just going to make a table. Today we're going to practice with making a table. All right, so to factor this very first one using the area model, here's what I'm going to do. I am going to make, it's 3 terms, so I'm going to go ahead and make 4 boxes. Now, when I make my 4 boxes, the first term, the x squared term, is going to go in the top left. The constant term, negative 12, is going to go in the bottom right. Now, these other 2 boxes, they have to be 2 values that add up to give me negative 4x. Okay, so they're both going to have an x in there. Now, I need something that would multiply to what is our a times c value. So I need 2 numbers that would multiply to negative 12. A is 1, c is negative 12. So 1 times negative 12 is negative 12. Now, the numbers that multiply to negative 12 also have to add up to negative 4x. Okay, so if I have negative 12x squared, what 2 terms could multiply to those? Well, I could say, I'm just going to go with the 12 for a second. I'll come back to that negative and positive. But I could say 1x times 12x would give me 12x squared. I could say 2x times 6x would give me 12x squared. And then I could say 3x times 4x could also give me 12x squared. Now, when I look at these 3 possibilities, these 3 combinations, I need one of them that has to be negative. And when they're combined, they need to be able to give me negative 4. Now, in order to give me negative 4, that means that the bigger one has to be negative. So I'm looking at those 3 options here. 1 minus 12 will never give me negative 4. So I don't care about that one. 2 minus 6, that gives me negative 4. 3 minus 4 would give me negative 1, so that's not going to work for me. So the 2 values that I need for these 2 empty boxes is going to be positive 2x and negative 6x. Okay, this is going to help us with that factoring that we need to do here. Now, when I'm looking at this, it's opposite of what we were doing before with distribution. So before we were multiplying. Now we're looking for the GCF of each row and each column. So when I look at x squared minus 6x, their GCF, what they both have in common, would be x. Okay. Now when I look at 2x minus 12, their GCF is going to be positive 2. Now, the reason that it's positive is because this first term is positive. So I'm going to take the sign of that box that's closest to it. So my first term, what I'm factoring, is going to be x plus 2. Now, that's each row's GCF. Now, let's look at each column's GCF. X squared and positive 2x, both of these have an x that I can factor out. Then the second column, negative 6 and negative 12, they both have 6 that I can factor out. And because the box closest to the 6 is negative, I'm going to take out a negative 6. So my second factor is x minus 6. Okay, so originally this student was multiplying x plus 2 and x minus 6. And that got them to x squared minus 4x minus 12. So again, instead of putting it together, we're pulling it apart. All right, so then let's look at the same problem looking at factoring by grouping. Okay, so I'm going to leave that answer there, and I'm going to do factoring by grouping. Now, my table is the same thing. Okay, so I do A times C. So 1 times negative 12 is negative 12. And if you remember, we said, negative 12x squared. We said that we could use 2x minus 6x. So I'm just going to go ahead and put those down here. So 2x and negative 6x. Those two values multiply to negative 12 and also add up to negative 4, combine to negative 4. All right, now, because A is 1, there's definitely a shortcut for this, and you can find that. But we are just practicing factoring by grouping, okay? So I'm going to keep x squared. Negative 4x, I'm going to break it up into positive 2x, negative 6x, and then I'm going to bring back the negative 12. Okay? So now instead of having 3 terms, we have 4 terms. Same 4 terms that we had inside the boxes before. Now when I'm looking at these 4 terms, I'm going to group together the first 2, and I'm going to group together the last 2. Hence why they call it grouping. Now when I'm looking at the first group, I need to find their GCF. So the GCF between x squared and 2x is x. Now, when I factor out an x out of x squared plus 2x, I'm left with x plus 2. Now that second group, negative 6x minus 12, first term is negative, so I'm going to factor out the negative. And they're both divisible by 6, so I factor out that 6. And then I'm left with x plus 2 inside the parentheses. Now, instead of having 4 terms, now I have 2 terms. Here's my first term. Here's my second term. Now, out of those 2 terms, what is their GCF? Well, their GCF is the parentheses. So I'm going to go ahead and bring out the parentheses. X plus 2. These parentheses have to match at this point. If they don't match, we need to go back to make sure that we factored out the correct GCF. There's no other option. These two x plus 2's have to be exactly identical. Now there's my first factor of x plus 2. Just like I had before, x plus 2. So where does my second factor come from? Well, that's the values that are not inside the parentheses. So I have x minus 6. And that becomes my second factor. Okay? So again, when we're doing factoring by grouping, we're breaking it up just as we did before, but this time we're putting it in 2 groups of 2. Okay? All right, so let's go on then and look at another one. And this time, A is not going to be 1. So on this one here, I'm going to take A times C, so 4 times 10, and that's going to give me 40m squared. I need all my values that multiply to 40, so I have 1m and 40m. I have 2m times 20m, and then I have 4m times 10m. I have 5m times 8m. All of these give me 40m squared. Now, when I combine them together, I want them to give me positive 22m. So 1m plus 40m, that would give me 41. 2m plus 20, that would give me 22. 4m times 10m would give me 14, and 5 plus 8 would give me 13. So the only one I have is 2m and 20m. Now 3 terms, so when I do my area model, I'm going to go ahead and make those 4 boxes. First term, 4m squared, goes here. Last term, positive 10, goes here. And then my 2 numbers, 2m and 20m, go here. Now 2m and 20m, it doesn't matter which corner box they go in, okay, but they do have to be in one of those 2. So looking at the first row, 4m squared and 20m, what do they have in common? They can both be divided by 4, so that's part of their GCF. 4 is positive, so the 4 on the outside will be positive. And they both have m. There's the other part of my GCF. The bottom row, they're both divisible by 2. That's the only thing that I can divide them both by. Now, the first column, they can both be divided by 2, and they both have m. So my GCF of that column is 2m. 20m plus 10, they both have a GCF of 10. So I have 4m plus 2, and I've got 2m plus 10. Those are the factors. Okay? All right, so let's do that again, but this time with factoring by grouping. So I'm going to keep the first term. The second term, I'm breaking up into positive 2m, positive 20m, and then keep the last term, positive 10. Group the first two together and find their their greatest common factor, their GCF. Their GCF is going to be 2m, and then I'm left with 2m plus, hold on, what did I do here? 4m squared plus 2m plus 20m. Okay, so then I've got 2m divided by 2m. I can see somewhere here that I have a mistake, and I've got to find it. So, you know what? Let's go ahead and make this mistake, and let's find it. So, you've probably already found it. So, these next two, what do they have in common? They both have 10 in common. So, if I take out a positive 10, I would be left with 2m plus 1. Okay? So then here, and I look at these, and I'm really baffled in my head right now of what I did. Maybe I had something different. I'm not sure. So the very first one would be 2m plus 10. And then my second one would be 2m plus 1. So the GCF of those two. See, but my problem comes when I'm looking at these two and I'm looking at this one. They should be exactly the same. So why are they not? So 2m plus 10 is in both of them. And then I have 2m plus 1. And I don't have 2m plus 1 on the other one. So I've got to look at that. And I'm seeing what it is right now is that because 4m plus 2, I could still divide those both by 2. And if I divided them both by 2, I would have 2 times 2m plus 1. And then I would have 2m plus 10. So different? Definitely. Wrong? No. I just still needed to factor out another GCF originally. Okay? All right, so let's go on then and let's look at what we have next. Oops. Keep that. That's not what I wanted to do. So our next one is I've got 2 of them for you to try. So you can use the area model or you can use factoring by grouping. All right. And then let me know if you have any questions with those ones, and then we'll look at those. All right. So the last ones that we're going to look at, though, are just factoring by grouping. Okay. So these ones here, I have 4 terms, which let me go back 2 slides. We actually had 4 terms here, too. We grouped them into 4 terms. We grouped them into 4 terms. So it's not going to be any different when they give us 4 terms. You can either use the area model or you can do factoring by grouping, whichever you choose. So I'm going to go ahead then and use the area model. So let me zoom in on that one. First term goes in the first box, 16a cubed. Last term goes in the last box, as long as they're in standard form. These other 2 boxes, you can put either one, either place. I'm going to go ahead and put 4x squared here, and I'm going to put negative 20a squared times b here. First row, what do they both have in common? They can both be divided by 4. 16 and 20 can both be divided by 4. They both have a squared. And because 16 is positive, 4 is going to be positive. Now the bottom row, 4 and negative 5. The only thing they can both be divided by is 1. 1 has a squared, 1 has b, so they don't have anything else in common. So my first factor is 4a squared plus 1. Now, to find the second factor, I look at each column. 16a cubed and 4a squared. They can both be divided by 4. They both have a squared. Second column, negative 20 and negative 5. Both of them are negative, but I always look at this first one. Since the first one's negative, I'm going to take out a negative. 20 and 5 can both be divided by 5. And the only variable they have in common is b. So my second factor is 4a squared minus 5b. Okay? All right, now let's do the same problem, but let's use factoring by grouping. Okay? So 4 terms. I put parentheses around the first 2 terms. I put parentheses around the last 2 terms. The first 2 terms can both be divided by 4. Their GCF is 4. They both have a squared, so that's part of their GCF. So what's left over? So, stop jumping. 16a cubed divided by 4a squared gives me 4a. 4a squared divided by 4a squared gives me positive 1. Now, the second group has a negative up front, so I'm going to bring out that negative. Then 20 and 5 can both be divided by 5, and both terms have b. So what's left over in the group? I have negative divided by a negative is positive. 20 divided by 5 is 4. A squared is left on the inside, and b divided by b, there's nothing left for b-wise. Negative 5b divided by negative 5b gives me positive 1. So now that I've got 2 terms, what is their GCF? Well, their GCF is a parentheses. So I have 4a plus 1. Then what's not their GCF? That becomes my second factor. So 4a squared minus 5b. Okay. Again, those are exactly the same. No confusion like I ran into last time. Exactly the same. Okay, so again, 3 terms, we turned it into 4 terms. Sometimes they give us 4 terms, and we have to factor them. All right, so here's 2 for you to practice, and that is it for this review. And I look forward to seeing you all back in class.